Okay, I suppose I can start now. Okay, so today's lecture would be on machine learning. Actually, this is just an introduction to machine learning. I won't dig deeper into what machine learning is and how we apply it to various algorithms. This is just to give you an idea and to hope that I can inspire you people to utilize machine learning to solve your particular research problems, of course, with the assistance of your supervisors. So let's start with the lecture. If the first, I would just go through the one of the many definitions of machine learning. This is a field of study that gives computers the ability to learn without being explicitly programmed. So whenever you people have gone through computer programming, you know how to write codes. So what you do is you provide several instructions to the computer to maybe solve a certain problem, to do certain calculations, whatever it is. But if you don't provide explicit instructions to the computer and allow it to learn itself, this is what machine learning is. And machine learning, frankly speaking, is everywhere. Not only in transportation, in fact, in transportation sector, machine learning came a bit later as compared to other fields, but it is present everywhere. So let's start with an example of how we humans learn and move forward with the experience. For example, a doctor is given a task to diagnose a particular tumor, whether it is malignant or benign. The doctor, what they will do is they will ask you to provide some tests like X-ray, ultrasound, biopsy, MRI. So these are different tests. So these tests will provide the doctor with certain observations. That is the clump thickness, uniformity of cell size, uniformity of cell shape, etc. These observations and the experience of the doctor is the thing that would allow the doctor to diagnose whether the tumor is malignant or benign. So if the experience of the doctor increases, the prediction accuracy or chances of predicting or diagnosing the tumor accurately as possible would increase. Like if you go to a doctor having an experience of 2 years, the accuracy might be around 60%. But if you go to another doctor having this having an experience of like 10 years in the same field, they would be able to predict the tumor much more accurately. This is how we humans learn, with experience. With experience and based on the observations, we can predict a certain scenario. So coming towards the machine learning and taking the same example, the task is to determine whether the tumor is malignant or benign. The experience is the medical records of the tumor diagnosis that we already have. And the performance measure is the number of correct detections or predictions. So coming towards another definition of machine learning, a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience T, E. So it's a bit confusing, but let me put it in simple words. In machine learning, you provide experience, that is the medical records. You keep on increasing the medical records to train the algorithm. The prediction accuracy of that algorithm will keep on increasing. This is what machine learning is. So you are providing the algorithm with data based on which it trains itself, it learns itself, and then it tries to predict on some unknown data. And that accuracy keeps on increasing when you keep on increasing the training data or the medical records. I hope by now you have understood the main concept of machine learning. So broadly speaking, machine learning algorithms can be divided into 4 very broad classifications. Firstly is the supervised learning, where you teach the computer and then let it use the learning to do the task. The previous example was for a supervised learning, where you provide the data having the classes known, the labeled data, like the observations, that is the clump size or clump shape as compared to the diagnosis, whether it was malignant or benign. So you have the labeled data. You provide that data to the algorithm to train itself, and then based on that training, the algorithm can further predict for future unknown data. This comes under supervised learning. Then is the unsupervised learning, where the computer is provided with unlabeled data. There are no labels, only the observations are provided. And the computer tries to make out the structure or the patterns within that data. So those patterns which we might not be able to understand or identify, those would be identified by the computer as using unsupervised learning algorithms. Clustering is a very common example of unsupervised learning. Then there is the semi-supervised learning, where you have a huge unlabeled data and a very small labeled data. So firstly, you allow the computer to learn the patterns using the unsupervised data or unlabeled data, sorry. And then you provide the labeled data to provide labels to those particular clusters that have already been identified by the computer. So this way, using a huge amount of unlabeled data and a very small amount of labeled data, you can solve your problem using semi-supervised learning algorithms. Lastly, the reinforcement learning. Over here, the computer itself tries to learn from the environment and take steps which would improve its performance. So I will not go deeper into any of these, because today's lecture is just an overview. And the feedback that I get from today's lecture would be the basis of my decision whether to go forward with some detailed set of lectures later on machine learning or not. So today I will just touch the important aspects of machine learning. So where is machine learning in transportation sector? This list is some of the problems where machine learning is applied. Some. It is not an exhaustive list. There are other scenarios where machine learning is also applied. For example, autonomous vehicles and connected vehicles. This technology won't be possible without machine learning. And a lot of research is being conducted in autonomous vehicles, in connected vehicles, in smart cities, smart transportation. And then there is an alternative to the discrete choice modeling. I believe you people have learned about discrete choice modeling either in your BS level or somewhere in your master's. You have learned about discrete choice modeling. The most common example would be the 12-mode choice modeling, where you develop a utility function, and based on the highest utility, you give it's a probabilistic method, or you can say you can convert the probabilistic problem to a deterministic problem as well. So based on the utility, the highest utility associated with the particular mode is then determined as the selected mode. So this is how mode choice modeling works. So it again is based on data. If you have data, you can use machine learning. So there is work being conducted as to apply machine learning as an alternative to the discrete choice modeling that is forever being present. The multinomial logic model is the most commonly used discrete choice model. Then there is the intelligent transportation systems, the traffic congestion prediction. So all types of predictions and forecasting, you will need machine learning, like the accident prediction, public transport occupancy prediction, human activity recognition, the travel mode detection. So whenever there is data, you can apply machine learning. And machine learning is foremost the most suitable, best solution, best tool that you have for your particular problem when there is data involved. Even you can use it for automatic traffic count by image processing. So image processing by video feed or by cameras, whatever it is, you can use machine learning algorithms, image processing algorithms to conduct your research. It's quite applied. And I believe in Lahore, we have the cameras installed. It's the Punjab Safe City Authority. The cameras that are installed and that are kept counting, or you can say recording the volume of traffic, it is based on image processing. So machine learning is working over there. Then there is delay prediction. It can be train delay prediction, bus delay prediction. So these are, again, this is not an exhaustive list. There are other scenarios where machine learning is also applied in transportation sector. I will just introduce one of the algorithms. Sorry, it's not a random forest, it's actually decision tree. Apologies for that. The decision tree is a very basic, very simple to understand algorithm in machine learning. So what you do is in decision trees, you repeatedly split your data set in order to arrive to a final outcome. So consider an inverted tree. You start from the root and you keep on moving through the internal nodes to the leaves or the terminals. This is how a decision tree is grown or it is developed. So the variables or features associated with the data, again, coming back to the first example, the clump size, the clump shape, the thickness, whatever it is, these are the features associated or variables associated with the data. Those are used to make the split at each node. And as the splitting progress, it reaches the terminals or the leaves, and each terminal corresponds to a target class. In our previous example, the target class was whether it is malignant or benign. So that is the target class or the prediction class. So let me give you a very simple example of how decision tree can be formed. Suppose that a person aged 33 years and having a PhD in his field, along with an experience of, say, 2 years, wants to apply for a job at a company. He has the previous hiring record, and he knows the variables that are important are qualification, age, and experience. So, for example, he has the data of like 100 previous hirings, where he knows the applicant's qualification, age, experience, and the target class, that is, was the applicant hired or not hired. So using that previous data, he can develop a decision tree, and using that decision tree, then he can see whether he stands a chance to get hired in that particular company or not. So starting from the root, from the first node, the algorithm of the decision tree, which it does is it scans through all the variables available, that is the qualification, age, experience, and selects the one that is best suited to make the split. So the first variable that is selected is qualification, and a split is made. So on one side is the master's, on the other side it is PhD. So based on the qualification, a split is made. Then we reach the internal node. And the internal nodes, again, a split is made based on, depending on the variable selected by the algorithm and based on certain values within that particular variable. This way, you keep on making splits until the algorithm or until the decision tree reaches the terminals or the leaves. And you can see each terminal node is linked with a particular target class, that is hired or not hired. Once we have the decision tree, we can provide the unknown data. For example, the unknown data in this case is age 33 years, having a PhD, having 2 years experience. So we can provide this unknown data to the decision tree and see what would be the outcome, what would be the prediction. So qualification, it's PhD. We go to the next node, age less than 35. We go to the terminal, that is hired. So based on the previous record, hiring record, this person stands a huge chance of getting hired. Right? This is how a machine learning algorithm works. And this is a very basic example, just to give you an understanding of how you can develop an algorithm. In fact, developing means training an algorithm based on given data, previous data, and known data, and then testing the algorithm based on some unknown given data. The second part of my presentation is based on a recent talk I gave at the Urban Transport Conference, having the title Regaining Confidence by Forecasting Crowding Levels in Public Transport. So over here, you would see how machine learning is being applied to a certain problem that we face in the transportation sector. So let's start with considering a scenario. Your car broke down and you won't get it fixed until a week later, but you have to commute to your office daily. What are the options available? So you have to use the public transport. But when you think about public transport, pictures like this pops into your mind: a crowded train. So you would have sweaty hands just by thinking about entering a train that much crowded. It will drastically decrease your comfort level. Now add to the picture a stylish looking virus that has the capacity to paralyze the entire world. You would be going completely insane by thinking about using the public transport with so many people in a confined zone with you. There would be heightened risk of contracting the coronavirus or any other virus. So even if you are not the first timer for public transport and you use public transportation regularly, you would think twice before entering a carriage like this. So this is one of the challenges the public transport sector is facing. Because of the COVID, the ridership percentage has drastically decreased. And one of the disadvantages, or you can say one of the obstacles in regaining that ridership, is the crowdedness levels. So nobody wants to enter a crowded train when you know that there's a virus over there, and you might be exposed to a person who already has that virus. So it's difficult to establish the safe distance from other passengers because it's a crowded cabin. What can you do? So how to solve this particular problem? How to improve the ridership of public transportation? For instance, now you are provided with crowdedness levels, predicted crowdedness levels on all the trains that are reaching your particular destination at different times. So for tomorrow, you know that the train arriving at a particular destination at say 8:52 would be having around about 40% crowding level, whereas the regular train that I use that reaches at 8:59 would be having 89%. So what can I do with this particular information? I may change my travel behavior, travel pattern, and move to a train that is less crowded. It will improve my comfort level. It would improve the ridership. This type of questions, whether it will improve your ridership, whether you would feel more comfortable, more confident in using public transportation. So some of these questions were asked to a small group of participants, small group of public transport users in Barcelona. The results suggested that around 40% of the participants believe that high crowding levels would increase the risk of contracting COVID or the COVID transmission. Then more than 85% participants revealed that if provided the crowding levels, the future crowding levels, they would intend to change their departure time or their route in order to use a less crowded transport. And then 50% participants claim that future crowding levels predictions or the information would improve the comfort level because they would be in a position to change their pattern in order to use a less crowded train. So hence improving their comfort level. So this was the results from a small study. Then let me present the preliminary results from my own work on occupancy, train occupancy level prediction. Over here, the data that I will be discussing is from only the Illawarra line that runs from the Central Station to Cronulla Station and the New South Wales, Australia. So when we look at the data, we see that it is highly imbalanced. So around 87% of the data instances relate to low occupancy level, whereas only 2% relates to high occupancy level and 11% for medium. So just looking at the data, you would see that it's highly imbalanced. What I did is, again, I'm not going into the details of how the algorithm was applied. It was just, I used 90% of the data. Firstly, I extracted some features from variables. As I have already mentioned, we require variables or features to train the algorithm. So I extracted some features. I used 90% of the data to train the algorithm, and I kept the remaining 10% to test the algorithm. So based on the prediction accuracies that I acquire, you can see the overall detection accuracy is around 97%. But there is a high disparity between the low occupancy level and the high occupancy level. For low occupancy level, the prediction accuracy is 99%, whereas for high occupancy, it is 66% only. So you can very well see the results are skewed towards the majority class, as you have already seen over here. Low is the majority class. So how we can solve this issue of imbalanced data? What I did is I applied, again, the same algorithm, the extreme gradient boosting algorithm. I applied it as 4 parallel algorithms having different data constraints, providing 4 different predictions, and then combining those predictions to get the final prediction. This way, I was able to improve the results, although the overall accuracy decreased by 0.41%, but the disparity of 32.35% decreased to 17.36%. You can see for low occupancy, it is 97%, for high, it is 80%, increased from 66%. But this way, we might be able to solve the issue of imbalanced data. Then comes the challenges that this particular problem and the application of machine learning can face. Firstly is the imbalanced data. As I've already shown you, that imbalanced data, it skews the results towards the majority class. So for the majority class, the prediction result would be very high. But for the minority class, it would be very low. This is the problem with imbalanced data. So how to solve it? There are certain methodologies that can be adapted for that particular problem to address the imbalanced data. I'm more concerned with the second problem that I would call as attracted occupancy. As opposed to weather prediction, for example, if tomorrow the prediction is it would rain, that prediction won't change with you changing your travel mode from car to train. No, but the travel occupancy or the train occupancy prediction would directly be impacted by your decision to change from one train to the other train. The basis of this approach is to change your travel pattern, but changing your travel pattern will ironically invalidate the predictions at the first place. So you changing your departure time from your usual train to a previous one would invalidate prediction accuracy or the occupancy prediction of that particular train, because you are now adding an attracted occupancy to that particular train. Let me give you an example for that. So for tomorrow, you see that a train that is arriving a bit early to your particular destination is showing a prediction the occupancy prediction or occupancy level of 40%. To make it more simpler, let's say it shows an occupancy of 10%. You see, okay, fine. I would like to, I can arrive at my destination a bit early. What happens is I would be using a less crowded train. Let me just change my departure time to a bit earlier to use that particular train. Likewise, some other passengers would also change their pattern. Tomorrow, when you board the train, what actually happens is you, along with 9 other passengers, have changed their travel pattern. Hence, now the occupancy is not 10%, it is 20%. Occupancy has increased. Although the prediction was like 10%, but the attracted occupancy has invalidated that prediction. So this is a huge obstacle to this particular vision, to this particular approach of improving the confidence level. It would, in fact, decrease your confidence level in this particular approach. How can we solve this problem? We can provide the public with exaggerated crowdiness levels. Let them change their patterns. Accordingly, we would be able to estimate the attracted occupancy. And in a stepwise manner, we can decrease the attracted occupancy, the publicly available occupancy levels to the actual ones in a stepwise manner, so that the attracted occupancy can be estimated and for a given time, and then can be accommodated into the equation. The vision is to be able to select a least crowded route as well. As, for example, if you use Google Maps, you are provided the option of best route, fewer transfers, less walking. Let us have an option of least crowded, so that we would be more comfortable in using that particular route, because we would know that in future, this particular estimation would be sufficient for us to change our travel pattern. Okay, this is all from my side. I would suggest that you people ask a lot of questions so that I would know how's the feedback. And again, one more thing, I would recommend, because you people, I suppose all of you are master's students, you people are already working on your particular research problems. I would recommend that you use machine learning to solve your problems, because machine learning is state-of-the-art method. It's a tool that is being used across all the fields around the globe. And further, we are now moving into deep learning now. So I will not discuss deep learning, but it is a specified subsector in machine learning that is now being used extensively. So any questions are welcome.